In this video, we're going to talk about a cumulative compound generator. It's the same generator setup basically we had as the self-excited generator, with the exception now is that we're adding this series coil. This is a coil that didn't exist before in the other types of generators. This is just another field coil, except it's in the armature path. And this series field coil is going to help us maintain field near rated current. If you remember in the self-excited situation, as we approached full load current, we had some issues with the field wanting to drop off at that full load current. We had some IA-RA losses, and therefore a terminal voltage loss, and therefore a field coil loss. So, in this situation, we're looking at this field coil dropping off because we had it connected across the terminals before, and we were losing field. So in this scenario, what we're doing is we're adding an additional field coil, and we're calling that an RS, an R series coil. So at rated current, what we're going to get is more flux being produced by this series coil. So we'll have a series coil producing flux and the field coil producing flux. Okay? So let me just draw in a rheostat here also. And what I'll do is I'll head this over like I'm going to connect it in, but there are two ways to connect it in. One way to connect it in would be to connect it down here, which would give us a short shunt. And another way would be to connect it up top here, long shunt. And, really, what are the differences? I'm just going to finish it up here and connect it in long shunt. And notice when it's connected long shunt, what I've got is IS here is equal to IA when I'm long shunt. IS equals IA when I'm long shunt. And that is not the case when I'm here short shunt. When I'm right here short shunt, IS equals IA minus IF, right? IS minus IF. I'd have IF leaving this way in the short shunt configuration. So in general, let's just talk about this long shunt and realize that they're going to work pretty much the same way. In the lab, we'll construct both. But what am I looking at for terminal voltage? Because that's really what I care about. The terminal voltage is equal to the generated voltage, and now I've got some losses in this long shunt configuration of IA-RA, and I have an additional loss of I-series, R-series. And when I'm long shunt, I-series equals IA. And if I were short shunt, that would not be the case. Short shunt I-series would be IA minus IF. So just keep in mind there's a little bit of difference there. So this is a cumulatively compounded generator. That series coil helps us build field near rated. It's a really thick wire because it's in the armature path. Not a lot of turns, but it will offset that terminal drop as I approach rated. Now, just one more thing. As I put that series coil in, I can put it in there so I'm cumulatively compounded, or I can put it in there so I'm differentially compounded. I can put it in there so the series field helps build flux, and I run my generator at rated voltage without a whole lot of drop-off. But if I put it in there differentially compounded, so it actually hurts me as far as making field, I'll get a special device here. What I'll get is essentially a welder. What I'll get is a constant current device, and we'll look at those curves in lab. If I put that in differentially, I'll essentially get myself a constant current device, a welder, over different voltages.
Made with Doodlecast Pro.